5.1 Systems of Linear Equations. So we're going to look at a 2x2 system, which means two equations with two variables. And what we need to know is if the system has a single solution, that solution occurs at the intersection point of those two graphs. So we're going to learn two algebraic methods to solve, and we could verify by using graphing technology and looking at the intersection point. The first method is called substitution. So the system, in this example, the first line is x plus y equals 9. The second line is 2x plus 3y equals 25. So what we need to do is in either equation 1 or equation 2, solve for x or y. Let me write that down. And the coaching point is just to pick the path of least arithmetic. So solve in whichever equation appears to be the simplest to you. So I chose to solve for x in equation 1 just because that seemed like the path of least arithmetic. There are 4 ways to start this problem, and all of them will result in the same answer. So you could solve for x or y in equation 1. You could solve for x or y in equation 2. So just pick whichever looks simplest to you. So I added y to both sides of equation 1, and I got x equals negative y plus 9. So this negative y plus 9 needs to go in for x, needs to be substituted in for x in equation 2. So if you substitute this back into equation 1, you will just get a redundant statement. You'll just get 0 equals 0 because you're plugging that, that line into itself. So we're going to sub out x in 2. So I've got 2 times the quantity negative y plus 9 plus 3y equals 25. So now we've got a single equation with a single variable. Solve as you always have. And for the sake of space at the bottom of the page, I skipped the simplification steps and we get y equals 7. Now remember that both lines have the same x and y for an intersection point. So this y value will result in the same x value if you plug it into equation 1 or equation 2. So again, pick the path of least arithmetic. I substituted 7 for y in equation 1, which gives me x equals 2. Now remember that the solution set is an ordered pair, so it does need to be written as parentheses 2, comma 7 parentheses. So the next method is called elimination, and the goal is to obtain opposite coefficients of x or y by multiplying as needed. So our system here is equation 1 is negative 4x plus y equals 6. Equation 2 is x plus 3y equals 5. So we want to obtain opposite coefficients of x or y. Again, there's 4 ways to begin this problem. Just pick whichever appears to be easiest to you. So what I did was I multiplied equation 2 by 4 and multiply the entire equation, and that gives me a negative 4 as a coefficient of x in equation 1 and a positive 4 as a coefficient of x in equation 2. Now, once you've got opposite coefficients obtained by multiplying one of those equations, then you add those lines together, and the variable that you have opposite coefficients will end up being 0. So now I've got 0x plus 13y equals 26. We can solve 13y equals 26 as we normally would. Divide by 13, we get y equals 2. Now from here, it's the same as the previous situation in substitution. Just sub y equals 2 into whichever equation appears easiest to you. So what I did was I plugged in 2 for y in equation 1 and solved for x and got negative 1. Write the solution as an ordered pair. Okay, but then what if the lines are parallel? So here we have two distinct lines. They're parallel, so their slopes are the same, but we have different y-intercepts. In this situation, there is no solution because there is no intersection point. Now, you can verify this by calculating the slopes. The slopes will be equal and the y-intercepts will not be equal. And then if you identify that, you know that there's no solution because there's no intersection. However, if you are solving using substitution or elimination, either one will result in a statement of 0 equals a number, and this is known as an inconsistent system. So that is your clue that these lines are parallel with different y-intercepts, and so therefore there is no solution. And then what if we have lines where the slopes are equal and the y-intercepts are equal? Well, to me, this means that they are the same line. So I guess you could think of it as two different lines stacked on top of each other. But what I want us to notice is that we end up with the same line, and if that's the case, the intersection occurs at every ordered pair, and then the verbiage to answer that problem, we would say infinitely many solutions. So if you are, I didn't draw a graph of this one because it would just be a graph of a single line to us visually, but substitution or elimination results in 0 equals 0. So here in this system, I have 2x plus 6y equals 5, 4x plus 12y equals 10. So you can, once you've done a few of these, probably pretty easily notice that these are the same line. Now, to verify that, if I begin my process of elimination and I multiply equation 1 by -2, I get -4x. So, and then in equation 2, I have a positive 4x. So therefore, when I add them down, I will eliminate x. However, in this situation, I've also got opposite coefficients of y, and the constants on the right-hand side are opposite. So when we add them together, everything is just going to unfold to be 0 equals 0. And this is your clue that these are the same line, or you could also say that they are linear combinations of each other. And then we would say infinitely many solutions because they intersect at infinitely many ordered pairs.